In this video, we're going to look at finding stationary points of a given function. And the first example we look at is find the coordinates of the stationary point of the following function, y equals x squared minus 2x plus 3. So we take a look at that. It's a quadratic equation. So we have y equals x squared minus 2x plus 3. We want to find the coordinates of the stationary point, so that is the turning point of this. Well, we'll find dy dx, the first derivative. dy dx is 2x minus 2. So we know that dy dx is the slope of the tangent at a particular point, and at a local maximum or local minimum, the slope of the tangent will be 0, because obviously if we're looking at a minimum, the tangent at this minimum will actually be parallel to the x-axis. So the slope of the tangent will be 0. So we set dy dx equal to 0 and solve for x. So simply 2x equals 2, x equals 1. Now we're asked to find the coordinates of this point. So we have here the x equals 1, but we need to find what the y coordinate is at that point on the curve. So let's sub in x equals 1. Y equals 1 squared minus 2 times 1 plus 3. So the x coordinate is, the y coordinate is 2. So the coordinates of the turning point, in this case it's a minimum, is 1, 2. And we'll just go, that's the first example, so let's take a look at another example. And the second example is find the coordinates of the stationary points of the following function. Y equals x cubed minus 3x squared minus 24x plus 10. This time we have a cubic equation, and the function is given as y equals x cubed minus 3x squared minus 24x plus 10. And again, we're trying to find the coordinates of the stationary points or stationary values. So dy dx, first of all, is 3x squared minus 6x minus 24. And to find the stationary points, we set the first derivative to equal to 0. Now I can just factor out the 3 here, so dy dx is 3 on x squared minus 2x, and that's minus 8. Negative 8, negative 2. Yeah, that should equals 0. So we know 3 isn't 0, so the quadratic x minus, so we were able to say that x squared minus 2x minus 8 equals 0 at the values of x. So we have 2 and 4, so we'll have a x negative 4 for our factors and x positive 2 equals 0. So our solutions for x could be x equals 4 or x equals minus 2. Now we're asked for the coordinates, so we really should sub in the value of 4 and calculate the y. So y equals 4 cubed minus 3 times 4 squared minus 24 times 4 plus 10. And I'll take up the calculator to do this. We have 4 cubed minus 3 times 4 squared minus 24 times 4 plus 10. That'll give me the y value of the first stationary point equals negative 70. So we have one stationary point identified, and I'll just write it up here, x, y. The first stationary point is 4 minus 70. And I go back to the calculator now and sub in negative 2 instead of 4. So let's look at, say, y here equals, take the calculator, and I'm going to edit the calculator values to replace the positive 4 with negative 2. And skip across. Each time I have the positive 4, I just delete and replace it with negative 2. And then the last one, I'll need to put brackets here because I need to make sure I pick up the negative. So bracket, back, delete, open bracket, and then inside here minus 2. That's correct. Okay, so subbing in minus 2, I get a positive value of 38. So we'll just note that there, 38. So the other turning point is minus 2, 38. So we've identified the coordinates of each of the turning points. Okay, so let's take a look at another example, and the next example we're looking at is find the coordinates of the stationary points of the following function. So this time we've got y equals 4x plus 1 over x. Take a look at that one. So y equals 4x plus 1 over x. Now we want to find dy dx first and set it to 0 to find the stationary values. So I'm going to rewrite the y in such a way that we can use our formula book to find the first derivative of this 1 over x, which is actually x to the power of minus 1. So dy dx, first derivative, equals 4 minus 1 times x raised to the power of minus 2. And we set that to 0. So I can now solve for x to find the value. So we have 4 minus 1 over x squared equals 0. I can bring the 1 over x squared to the other side. 1 over x squared, and I can cross multiply maybe by x squared, so 4 x squared equals 1, x squared equals 1 over 4. Take the square root of both sides now, and I will end up with two values of x. We have to take into account that x would be plus and minus 1 over the square root of 4, which is 2. So we have two values for x, so x can be positive negative a half, or x can be positive a half. So let's just plug that in to find a value of y. So we'll do it for the positive one first. Y equals, I just go back to the calculator, clear down what's on the calculator there. So we're looking to do 4 times a half, 4 times 1 over 2, and close bracket, x to the power of minus a half plus, open bracket, 1 over 2 raised to the power of minus a half, minus 1, excuse me, raised to the power of minus 1. So that's just substituting the positive value of a half for x, and we get y equals 4. And we go back and substitute the negative a half on our calculator. So I'm just going to edit the screen to make this one negative and make the other half negative. Back and back. We just put a minus in there. Okay, so we should get the value -4. That's what I was expecting. So y equals -4. So those are our coordinates of the turning point. 4. Oops. We can write the answer just to make it clear. And -1/2 -4. And yes, that's all for this video. Thank you for watching.